Okay, now we have lecture 9 on gas chromatography and IR spectroscopy. So for GC, essentially what happened is we injected our sample, just like our column. We loaded our sample on top. This is where it is. And then we have helium gas that acts as like a mobile phase that passes through the column and force the compound to separate. But helium is a gas and the sample we injected is liquid. So for the compound to separate, they actually have to convert to they have to go to gas phase. And this is what the oven is for. We want to evaporate the liquids to gas. And GC doesn't really care about polarity. No polarity or interested. Because the separation is mainly based on the gas. And the gas separates based on their boiling point. So that's why as time passes through, the machine will detect the gas at a certain time. And this one will be a low boiling point. The one that comes out later will be the high boiling point. And once we got our chart out, he might ask you to calculate the concentration of B, and he will give all the areas, and you just have to follow this formula and plug in the percentage. And then you can get the area of the peak out. And this is so this semester you guys didn't get a chance to do GC, and so it's for the people who are doing Ester Part 2 in the following week or tomorrow. This is no longer part of the experiment in this semester, but in the future they will. And you can kind of see that we have some sort of area right here. This means that I have 98% of the ester, the 1% is air, and the 2% is alcohol, which is really minor. But that was fine. And here's a question from the past year repeat. The question asked, let me see, what the value of the parentheses next to each peak is, what's the purity of the ester? So we know that the peaks, the longer the time, higher the BP. So we only have 2 peaks here. One is the 156 degrees and 130. This one is the ester, because it has a higher BP. And this one is alcohol, because it has low BP. So for that, the answer will be B. And then we have another question. This is really wordy, and I'll point some of the stuff out, and you guys can work through it. So which of the following statements accurately identifies the peaks? So we have our ester, we have our acid and alcohol. Tell me which peak should be this. Yep. Yeah. So peak 5 is ester. So peak 5, that's wrong. That's wrong too, because it says peak 5 is acetic acid. And now we only left with some other minor differences. And here it says peak 4 is alcohol. Peak 4 is alcohol. And peak 4 is alcohol. So that remains constant. Oh, here it says acid. Which one should be the fourth peak? Based on the question that was given. Yep. The fourth peak should be the alcohol. So whoever says peak 4 is acetic acid is 0. And now we left with only B and D. And the only difference is either peak 1 is water or peak 1 is air. The air contamination peak is very, very small. And just like the one I have right here. So the air peak will not be this high. So that's why the answer should be D. Any questions?
If they didn't tell you that it was if they didn't have alcohol as the impurity, could you assume that it would be the acetic acid, because in the synthesis acetic acid is going to be excess?
In the synthesis, yes. And according to Dr. Hossein, by the moment you finish extraction, all of the acid should be out. But if it happens that it goes through, it will appear on the peak. But say that it was a given that the alcohol will be here. Like the question didn't state it, like this doesn't exist. And we don't have this peak, then yeah, the second highest peak, the second longest time would be the acid. Yeah. So it all relates with according to their boiling point. And we know that 2 is and we know that 2 or 1 is water because they are lower than 3. The boiling point is 100. Okay, next. And now we are on IR. So normally we have 2 molecules diatomic. They can vibrate, right? The more energy you give, longer the bond will stretch. But at what point the energy will be so high that the bonds will dissociate. So the bond will broken and leave with 2 molecules. This is what the Morse potential gives. And harmonic, it just assumes that the molecule will just keep on extending, and will never break. So that's why it's keep going up and doesn't level off. And in the lecture quiz, in past theory quizzes, Dr. Rudick tested how to operate with the harmonic oscillator, which is this trend we're working with. We don't have to worry about Morse, but that one is the realistic. So for harmonic oscillator, you guys just have to how to operate around this part of the formula. And we got that from 1/2 pi, and yeah, times the light speed in centimeters. and the square root of Avogadro's number. And this is one of the questions from last year's exam. And I want you guys to calculate the reduced mass and report me what's the wave number after the NH is replaced to ND. And remember, the units here is in atomic mass. And the force constants, let's see. You have to convert this number to kilograms. And once you got the numbers out, then you can determine that did it increase substantially or slightly, or decrease slightly or substantially. Actually, you guys don't have to convert it to kilograms. And you just need to calculate for ND because NH was given. We just have to know after the hydrogen is replaced to deuterium, how will the stretch become? By the way, it's 6 p.m., so it's already exceeded the time that I expected to go through. There's 2 other lectures left. So the one who would like to stay with me can stay here, and the one who runs out of time can leave, and I will have the recording available. It will be, I hope it's 30 minutes after the section ends. Yep, it's C. Can anyone tell me what was the wave number you guys calculated? But yeah, after calculation, you guys should have around 2,400 wave number. And that is really, really low compared to the range we have here. And of course, we replace hydrogen to deuterium, we increase the mass, and therefore the wave number should decrease. So by first sight, it says the wave number increased, and that's incorrect. And we change the mass, so it does change. Leave it B and C. And because we did the calculation, and we know that it did increase substantially by almost 1,000 wave number, that's a really big shift. So that's why we know that it's C, not B. Sure. So for the calculation, let me use a whiteboard. We have wave number. equals to 100, what is it? 0.3 times the force constant. It was given to be 600 divided by reduced mass. And we are solving for ND. So this is our mass 1, mass 2. And according to formula is M1, M2 divided by M1 plus M2. So that'll be 16 times 2 divided by 16 plus 2. And you plug that in, do the calculation, and you should get 2393.76. Which number? Welcome. And let me switch to PowerPoint. And here's some features for different molecules we're interested in this experiment or this lecture. First is the alcohol in gas phase. Because the molecules are further apart, instead of sticking around like one another like really closely, the alcohol peak would be like normal peak, which is the alcohol peak for gas would be just like really sharp. But for liquid phase, they are close to one another, then they are constantly dissociating the hydrogen bonds or the hydrogens. That's why the bond is, that's why the OH stretch. Is broader because it can also interact with other OH. That's why it's really broad. In gas phase, we don't have to worry about this. Do we have to order? So suppose that he didn't ask this part. He only asked the how will the frequency change, like the decrease. Usually just three options, like did it change, did the frequency decrease, or the frequency increase. But in last year's exam, he did ask you to how did it change, like what's the degree of it. So that's the part where you have to actually calculate it. So I do recommend you to actually memorize how to use this formula. And then for Ester, we don't have any OH stretch. So that's why we don't observe anything here. And then for Ester, the carbonyl peak is very special compared to normal. Normally it's around 1730 to 1710, lower than the Ester. But yeah, this is around this 1/5. This is 16. Sorry, 1, 2, 3, 4, 5. This is 16. This is 15. And this is 17. And this is and you can also have the chart on the side, or maybe it's probably in the exam. The carbonyl stretch is strong and sharp. So that's a sign that is ester. For carboxylic acid is somewhat lower. You can see that it's around 1710. Instead of the ester, which is like right in the middle, 1750. And for carboxylic acid, it has this kind of internal hydrogen bonding, intramolecular hydrogen bonding. That is the main reason that why instead of the alcohol group in here, it's being shifted to the right. Because the bond is actually stronger it takes more energy to stretch it. And based on the previous knowledge, can you guys tell me which molecule should this be? Is it the alcohol, acid, or ester? Right, Jonas got it. So carbonyl is really strong and sharp, and we don't have it here. So that immediately crosses out any carbonyl peaks, which is no. And for the acid, the acidic hydrogen, the acidic OH bond, acidic, it ends at somewhere here. So the acidic OH stretch is actually in between this 3400 to 2500. And we don't observe that here. It already ended somewhere here with just alcohol. And then here's the next question. Just saying this one is tricky. Which molecule should this be? So I got an answer from Anthony. Anyone else? Yeah, right. Let's see. So here we have yeah, that's correct. So here there's carbonyls, right? But we don't have carbonyls here, so that's 1, 2, 3, 4, 5, 6, 7. We don't have carbonyl peaks here, so we can say bye-bye to them. And then we don't have any alcohol stretch, so nope. And for this, we have carbon bond stretches, 2 of them. And this is a CO stretch, a very strong one. And you can refer back to the chart. So for carbon oxygen single bond, that should be strong. So that can be your explanation to how did you reach to your conclusion. You can say that you observe that there's no carbonyl stretch, no OH stretch, and that's how you eliminated answer choice A, B, and D. And that sums up for the materials for lecture 9. And if you have any questions, please let me know.